Let S be the set of complex numbers satisfying these two inequality. One is mod Z minus 3, this is less than or equal to 1, and the other one is Z into 4 plus 3 iota plus Z conjugate into 4 minus 3 iota, and this is less than or equal to 24. Obviously, the first one will represent all the points inside a circle or on the circle with center at 3, 0 and radius 1 unit. And in order to identify the second locus, in place of Z, we'll substitute x plus iota y. If alpha plus iota beta is a point in S which is closest to 4 iota, then we have to find the value of 25 into alpha plus beta. So in this problem, first basically we have to plot the two locus, and then we have to identify the complex number which is uh, in that locus and is at minimum distance from this point 4 iota, right? So let us plot the diagram and then see what kind of locus we are getting here. So let us say this is our imaginary axis and this one is the real axis. The very first locus is mod z minus 3 is less than or equal to 1. If I had equality sign there, then it will represent all the points on a circle with center at 3, 0 and radius 1 unit. But we have less than or equal to sign, so that means we have points either inside the circle or on the circle. Also, the second locus is this one. So in place of z, let us substitute x plus iota y. So we have x plus iota y and this multiplied by 4 plus 3 iota, and z conjugate means x minus iota y and this multiplied by 4 minus 3 iota, and this should be less than or equal to 24. Now see here, right hand side is a real number, so this inequality will make sense only when the left hand side is real. So that means iota term will cancel, right? So let us write the real part only. You will get real part as 4x minus 3y. If you want, you can write the imaginary part also, but it will cancel from the two terms. So, and similarly 4x, and from here you will get minus 3y. This is less than or equal to 24. So from here we are getting this locus that 4x minus 3y, 2 we can take common and then we can cancel. So minus 12 less than or equal to 0. So this is the locus that we are getting, 4x minus 3y minus 12 less than or equal to 0. So this will represent any one side of the line. If I had equality sign here, then it will represent points on the line. Inequality means any one side of the line. Also, for this circle, the center is at 3, 0. And you can see that this is a line passing through point 3, 0. For this line, the slope will be positive. And if I make y 0, x will be 3. If you make x 0, y will be minus 4. So it is a line with positive x-intercept and negative y-intercept. So this is the line that we are getting. Right? If I had equality sign, then it will represent all the points on this line. But because of inequality, it will represent any one side of the line, either this upper side or lower side. Now, if I check with origin, because it is always easy to check with origin. So if I substitute 0, 0, it is satisfying this inequality, right? 0, 0 will satisfy this inequality. Minus 12 is less than 0. So that means it will represent the upper side of this line. So points inside the circle and also on the upper side of this line. So that means this is the intersection of the two inequality, right? In this shaded region, the point, S is representing all the points in this shaded region. Now, alpha plus iota beta, this is a point in S which is closest to 4 iota. Now 4 iota will be somewhere here. This is point 0, 4, right? This point will be 0, 4, and S is a point in this shaded region, and the distance between these 2 points, let us call this point A, and you have some point P in this shaded region. So the distance between point P and A, that should be minimum. Now we know that minimum or maximum distance of any point from a circle is always along the line joining the center of circle with the given point. That means if I join these 2 points, let us call the center of circle is at B. So if the point P is this one, then the distance AP will be minimum. Again, I'll repeat, point P can be any point in this shaded region. Now we have to find that particular point which is at minimum distance from point A. So if I join point A with the center of circle, and if P is the point of intersection of line joining OB with the circle, then this is the required point, right? This point will be the point of minimum distance. So if this point is alpha beta, the coordinate of P will be alpha beta. Now, there are different ways of finding alpha beta. One, you can write the equation of this line AB, the equation of circle, and then you can then you can find their point of intersection. But another easier method will be that you can use section formula. For the circle, the radius is 1 unit, so this length PB is 1, and also uh, this length AB, that will be root over 3 square plus 4 square, that is 5 unit. So that means AP will be 4 unit. So now P is a point which is dividing AB internally in ratio 4:1. So therefore, if I find alpha here, alpha will become 4 into 3 plus 1 into 0. So that will be 12, and that divided by 4 plus 1, 5. So using section formula, this will be alpha. And similarly, beta will be 4 into 0 plus 1 into 4, and that divided by m plus n, so 4 plus 1, 5. The problem was we need to find 25 into alpha plus beta. So alpha plus beta, that will be 16 by 5, and then 16 into 5, that will be 80. So that is the correct answer for this problem, right? So this was again not difficult problem, just we had to plot the inequalities. First one circle, second one side of the line, and then maximum minimum distance of any point from a circle is always along the line joining that point and the center of circle. So from there we got this point P, and using section formula, this was the coordinate of P. Finally, our answer will be 25 into 16 by 5, that is 80.